Welcome you all to this video on load flow analysis. In this video, we shall continue with our learning outcome number one, that is load flow problem. And particularly in this video, we shall deal with power flow equation. This is very important equation in load flow study because the entire load flow study depends on this one equation, power flow equation. So this equation actually gives how the power flow, give the idea about how power flows into the system. So let us derive this equation in this video. So let us start. I will take an example here. We'll start with an example of three-bus system. Then we shall generalize this system. So consider we have a three-bus system here I have shown. Let I am giving the numbers. Let this bus, it is as number 1 here, and this as number 2, and this as number 3. We have considered a three bus system here. Now let us consider the admittances. These are the transmission line, three transmission line. Let the admittance of this line, that this line, it is Y12, then this transmission line, the admittance is Y13, and let the admittance of this transmission line as Y23. Further, let us consider the voltages. What are the voltages at the buses? So this is bus number 1 we have considered. Let V1 be the voltage at this bus. Okay, and this is in per unit. Okay, and now here whatever quantities I'm showing, the admittance, current, or maybe voltage, they are all in per unit. Okay, let the voltage at this bus number 2 be V2 per unit, and the voltage at third bus, let it be V3 per unit. Let these are the currents that are injected to this bus. So I1 be the current injected to this bus. This is the net current that is injected. So in last previous video, I have told you what is net active power injected or net reactive power injected. This is the difference between generation and load. Okay, so I2 be the current, net current injected to this bus number 2, I3 be the net current injected to bus number 3. Okay, so let us start with this. Now what I will do, I will write a equation. So let us write, I will write one KCL equation at, write KCL equation at bus number 1, bus 1. Okay, now this I1 is entering to this bus, so I will write it as plus I1. Now let us find out the current in this line. Now here we can see the potential is V1 here, the potential is V2, and as per Ohm's law, we know that V is equal to IR. Write it somewhere here. Uh, okay, V is equal to I into R. It is from Ohm's law. Or we can take this as, or we can write I is equal to V by R, or if you take R in the numerator, it will be G into V, or in more general terms, it can be Y into V. So admittance into voltage. V is the potential difference. So in that term, what I can do, I can find out this current as the potential difference is V1 minus V2, and admittance is Y12. So I will get this current, and this current is leaving, so I can take I1 is equal to leaving, so it is minus, so I can take this as minus V1 minus V2 is equal to Y12. And if you take on another side of the equation, so I will take it as sum of current entering is equal to sum of current leaving. So sum of current entering is I1, and this is the current leaving, plus I have to find out this current leaving also, this current in this transmission line. So that can be written as the potential difference V1 minus V3 into y13. So now I can arrange the terms, I can collect the terms v1 together. So I will get y12 plus y13 into v1, then minus I can have y12 v2, and then I can have y13 v3. Okay, now in terms of admittance parameters, in terms of uh, parameters of y bus, what I can do, I can write this as y11 v1. So what is y11? Y11 is y12 plus y13 my plus y12 into v2 plus y13 into v3. So what is y12? Y12 is nothing but minus y12, that is admittance of second line. Okay, y13 is minus y13, the admittance of the another transmission, third transmission line. So let this equation be 1. Now similarly, we can write a KCL at, we can write one KCL at this point, and we can write one KCL at this point. So we'll get three equations. Okay, if you put all of these equations in the matrix form, then we will get these equations, what we call it as network equations with bus frame of reference. In the electrical circuit analysis, we have called it as nodal analysis. Okay, but here the node, here the buses represent nodes. So let us call it as bus frame of reference. This is what is the a name used in the literature. Okay, so we will use bus frame of reference. Now what is that equation? So if you put all these three KCL equations in the matrix form, we will get it like this. So you can see here I1, the first equation here, the first equation I have written here, I1 is equal to y11 into v1, y12 into v2, y13 into v3. Okay, so what is y11? It is already written here. Y11, it is equal to y12 plus y13. Y12 is equal to minus y12, and y13 is minus y13. Now, if you write, I do not write it here, but you try of your own. You write KCL equation at 2, and you see that you will get this equation as I2 is equal to y21 into v1 plus y22 into v2 plus y13 into v3. So what is y21? Y21 will be equal to minus y12, y22 will be equal to y12 plus y23, and y23 will be minus y23. Similarly, you write KCL equation at this third bus, and you will see that you will get the third equation I3 is equal to y31 v1 plus y32 v2 plus y33 v3. And what is y31, y32 and y33? You will get these equations here. y13 is equal to minus y13, y32 is equal to minus y23, and y33 is equal to y13 plus y. Now what this matrix is called as? This matrix is called as Y bus. This is called as bus admittance matrix, and these are all its parameters. Okay, this Y bus can be found by inspection also. So that is one more important point. Now how you find these diagonal elements, if you look at, this is Y12, Y11, Y12, Y22 and Y33. These diagonal element, they are the total admittances. I will write somewhere here what are diagonal here in this matrix, what this diagonal parameter represents. Diagonal parameters, they represent the total admittance connected, total admittance of lines connected to that particular bus. For example, suppose I am finding y11. Y11 is equal to, now you look at this bus here, this is bus number 1. So at this bus number 1, this line is connected and this line is connected. So you add the admittance of these two. So that is what we have obtained here. Y11 is equal to Y12 plus Y13. Okay. Similarly, you can see here Y22. If you look at this Y22, this is also diagonal parameter. Y22 is the total admittance. These are the two transmission lines connected. So it is Y12 plus Y23. Add the admittance of these two lines. Similarly, Y33, it is the admittance, total admittance connected to this bus number 3. It is equal to this admittance plus this admittance. So you have to remember this, that the diagonal elements of this matrix Y bus, they are the total admittance of the lines connected to that bus. Now what about off diagonal? So let us understand what is off diagonal. Now I will take this example Y13. Now what is Y12? Y12? Y12 means what is the admittance of the line connected between 1 and 2. So this is bus number 1, this is bus number 2, and this is the line connected between these two buses. Now the admittance of this is Y12. Y12 is the admittance, and deliberately we put minus sign to this. So we will get this parameter Y12 parameter of Y bus. So we can see here Y12 is minus Y12. Similarly, Y13 is the negative of the admittance of the line connected between 1 and 3. Y21 is negative of the admittance of the line connected between 1 and this is 1 and 2 are 2 and 1, that is not difference. So you have to understand that here Y12 is equal to Y21. They will be, this Y bus will be a symmetric matrix, will be symmetric matrix. Similarly, Y13, it will be equal to Y31. Okay, so this is how we have to find out the off diagonal element of this Y bus. Now finding these parameters in this way, it is called as Y bus by inspection method. Now this method we can use provided that there is no mutual admittance between the lines. If there is a mutual admittance between the lines, then we cannot form Y bus by this method. So we have to take care of this. Okay, then we have another singular transformation method, that is a concept in the graph theory. Okay, that you will going to learn in this subject, CMPS, 7th semester subject. Okay, now let us, now what I will do here, I will write the equation for I1. What is I1 here? So I1 I will write, I1 is equal to Y11 V1 plus Y12 V2 Y13 into V3. So similar equation I have written, I1 is equal to this equation. Now I am putting it in the summation form. I am putting it in the summation form. That is Y1k into Vk. So and k varies from 1 to 3. So you can see here. Now what you do? Now to get the first term, you substitute k is equal to 1. So here I substitute 1. Here I substitute 1. So I will get the first term y11 v1. Then plus, then you substitute for k equal to 2. Now if I substitute 2 here, I will get the second term, that is y12 v2 plus, then I will substitute the third term k is equal to 3. We have to go up to 3 last, that is our system is third, only it has 3 buses. So we will get the last term as y13 into v3. So we will get the same. Here what I have done, this summation, whatever it is there, it is put it in summation form. This sum of the terms, it is put in summation form. Okay. Now let us see in general. Suppose this is very very important point. Now I am going for general system. Now I have n bus system. Now I am not taking 3 bus system or 2 bus system like that. I am taking in general, there is a system where we have n number of buses, and current at the ith bus, there is one bus which is named as ith bus. Now here I have written equation for I1, that is the first bus. but I am going to write the equation for ith bus. What is the current equation for the ith bus? So now what are you doing here? I1 here, whatever is there, I am substituting by I. Okay, that is I am writing current equation for the ith bus. This is for first bus. So I equal to, now I am considering n bus system. I am not considering 3 bus system. I am considering n bus system. So k is equal to 1. So here you can, now here 1 I am substituting by I, 1 I am substituting by I. So we will get yik into vik. Okay, now I have developed a current equation for a system. We have n buses, and the current equation is written in general for ith bus. That is some number, the bus number, it is I. Okay, so let this equation be 1. This is where you remember that this equation, let it be 1, because here we are going to substitute something in the later derivation. So let this equation be 1. Now let us continue our derivation. But there is important, this equation is very important. This is called as complex power equation. How it is derived? Now suppose if I have a bus, now I am taking it as ith bus. I am taking it as ith bus. The number of the bus is I. Okay. Now to this bus, let I be the current injected. Okay, this is from generator, or okay, and let Vi be the voltage of this bus. Vi be the voltage of this bus. Now, how I can write the equation for complex power? So, equation for complex power, as we know that, what is complex power? Complex power, it is having real and reactive power together. So, what is complex power equation? It is Vi into II conjugate. II conjugate. These two are both phasors. You remember, this is also phasor. Vi, it is a phasor quantity, and II, it is also phasor quantity. And if you multiply these two, I will give you an example. Suppose Vi, suppose this is 1 at an angle, say 0. This is in per unit I am talking about. II, say it is equal to, say, zero point 0.7 at an angle 30. This is also phasor current. So what is this? So Vi, it is 1 at an angle 0. This is my first voltage phasor, into current phasor is 0.7 at an angle minus 30. Now why I am taking minus 30? Because the conjugate of this, the angle gets negated. So it is minus, so this is my current phasor. So voltage phasor into current phasor, so it will be 0 0.7. So 1 into 0.7 at an angle 0 plus minus 30, so it will be plus 30. Now you can see this complex power, this is also phasor. Now if you convert it into rectangular form, then we will have P minus J Q. We will have a real part, and the real part, it will give you the active power, and Q, the imaginary part, will give you the reactive power. So this is called as complex power. Okay. Now this equation you have to remember. At a particular bus, if I have a voltage Vi and if I have current II, then how to get the complex power at that bus? So V into I conjugate. So you just in general you can remember this equation V I conjugate. But now what I will do, I will take conjugate on both sides. So actually this is P plus JQ. Okay, now I'll take complex on both sides. So if you take complex on both sides, P plus JQ conjugate is equal to V conjugate, I conjugate, and one more conjugate to this. So conjugate get cancelled. So we will have V conjugate into I is equal to P minus JQ. So this is the equation, what I am using it here. So you can see this equation Vi. So I am taking now ith bus. So I am writing it as Vi Vi conjugate into I is equal to Pi minus JQi. This is a complex power equation at ith bus. Okay. Now what we will do, we will modify this equation. This Vi we will take on this denominator. So Pi minus JQi divided by Vi conjugate. This is the equation I can write. This is easy to understand. Now substituting into equation 1. In the previous equation we have derived equation II. Okay. II equal to, I think, II right here. II equal to summation Yik into Vk. So what I will do, in place of this I will substitute this part, I equal to this part. So we will get this equation as, so this is our II, this is our II term, okay, equal to summation Yik into Vk. Okay. Now what we will do, here Yik, suppose if I split up, it will be look like Yi1 V1 plus Yi2 V2. So likewise we will have, and in general I will take one Yii into Vi plus it will continue. So there is one term called as Yii into Vi. So what I will do, we will take this one term out. So I will take Yii Vi, I will take common one term out, plus and other term I will still put it in summation form. So this will be k is equal to 1 to n and k is not equal to I. So this is what is written here in this equation. So Pi minus JQi divided by Vi and Yiivi minus Yii, that is what, that one term is taken out, minus summation k is equal to 1 to n Vik, k is not equal to I to n. Okay. So this equation you will get. Now this is called as power flow equation. This is called as power flow equation. This is very, very important equation you will have to remember. So I write it once again. Pi minus JQi divided by Vi conjugate equal to Vi minus summation Yik into Vk. This term you have to write the limits, lower limit, k is equal to 1 to n, but k is not equal to I. This equation is called as power flow equation. Very, very important equation in load flow studies, because the entire load flow study, it is proceeded with this power flow equation. Okay, so I hope you have understood this power flow equation. Uh, the After this only in this video, we shall continue further part in the next video. Thank you very much.